Welcome to this event. I'm really amazed as well to the turnout. I think we literally were thinking that there'd be just a couple people here, so it's fantastic to see everyone. I thought I would kick this off just talking a little bit about what I find so special about Reagent. Reagent's something that I've not been doing for a long time, maybe if you say 3 months, I'll say 4 months.
He taught me.
But it has been a fantastic framework. And I know for Loyal 3, it's something that we've adopted in production, and all new projects are actually built using this framework. That's how strongly we feel about it. So what I'm going to talk about tonight is really kind of my journey there, and some of the ahas we had along the way, and some of the things we looked at. Could I get someone to drive? Awesome. All right, so all this began not where you'd expect it to begin. And it began with a search. The search really was the search for one of these, the mythical unicorn. Originally, what we were looking for was full stack developers. And by full stack in our world, it meant Scala, Java, Mongo, Rake, Redis, MySQL, Vagrant, JavaScript, Express. It was a tremendously long laundry list of things. And what we found was that we ended up bogging the developers down more than we were enabling them to do their job productively. And so really what this caused is for us to kind of rethink, maybe we were doing the wrong search. Maybe instead, should have removed the word framework. Maybe what we want instead is something else. So we thought about that, and I came up with a bunch of things. The first thing was, instead of trying to find people, maybe what I'm looking for is this stack is the wrong stack. So if I want to pick a new stack, what are the features I want? The first feature, and this is really important to me, is it has to be simple to reason about. I've worked with a number of frameworks where when you look at the code, it's not always clear what's going on. I have this a lot with jQuery frameworks where there's a lot of update cycles going on. You don't really know what state you're in, so you're not exactly sure what should be happening at this particular point. This is also true for anything where you're doing a lot of updates because you're not quite sure where the changes to state are coming from. It's really hard to think about at this point in time, what should this page, what should this event, what should this thing look like? So for me, I want the library, the tool, to be one where if I look at it, I understand exactly what's going on without a lot of time. It's unambiguous. Next one. So the second one to me was that it had to be easy to explain. I think we've all experienced frameworks. There's been an explosion of JavaScript frameworks. There are many frameworks where even with a very sophisticated JavaScript developer, if I sat down with someone that didn't know the framework and explained it to him for an hour, it wouldn't be enough. A day wouldn't be enough. A week, maybe. And I think you know some of the frameworks I'm talking about. The challenge is, if it's so difficult to explain, will people do the best practices? Will they do the right thing? Will they be likely to copy and paste? The more difficult it is to explain, the more likely you're going to see these really bad behaviors if they understand what's going on at all. And it usually means that as the framework changes, it's very difficult for developers to keep up with it. So being easy to explain was really important to me. Another way I think about it is, how quickly can people be productive? If I have to spend a month, 3 months training a team on how to use something, that's a whole lot of time spent just learning this tool that might not be applicable anywhere else. Next. This is also very near and dear to my heart. It grows gracefully. I have worked with a lot of frameworks where they look very pretty, they demo fantastically, but as the framework expands, as you use it for more and more things, as the application builds, it gets increasingly more complicated to maintain. to the point where it just turns into this big ball of mud, and nobody really wants to deal with it. So any framework, any library, any application can turn into that ball of mud, but I want something that resists it. As much as possible, it kind of encourages the right behavior, for whatever you think right is. All right, 2 more. This one also key. I want to be able to share the code so that if I have teams working on it, I need some way to maintain a consistent look and feel, consistent style. If I have complex interactions, inputs tend to be horribly complicated with everything from inline validations to renderings to responsive, etc. I don't really want to have to write these over and over for every app we make. I want to be able to share them. And the last one is that it's reliable from the start. If there are problems, I want the problems to be my problems. I want to be the weakest link in the chain. I don't want to have to worry, there's something weird going on here. Is it me? Is it the framework? And I know that's a lot to ask for a library or tool on day one, but without that, it makes it really hard to build your business on top of it when you just don't know where the problems lie. All right, so where I started this was going through a number of JavaScript frameworks. We thought about doing it the more traditional server-side manner, but we found that what the business wanted more and more was interactive pages. So we were being drawn into creating jQuery and things like that. So given that we knew we wanted more interaction, it was probably going to be a JavaScript framework. Of all the frameworks, this was the one that was the most compelling. So here I'm going to steal blatantly from the React creators presentation. So React, who here is familiar with React? Oh God, you guys are all familiar with it. Anyone use React in production? Or just using React on a regular basis? Okay, got it. So I'll go quickly through this section. So it's a library, it renders a UI, responds to events. Flip forward. AKA, it's the V in MVC. And the key thing here is components are a first-class citizen. A component is a logical element on the web page. If you were to see a typical web page, you might have a component being the upper right-hand side where you've got the sign-in information. You might have a nav bar as a component. It's any logical thing where you might want to put a div around it. In fact, for many pages, you might see an actual line around that, a box around that area. And so it allows you to take these components and assemble them together to create your web page. Here's how I think about this, and here's part of why I love React. I get a single flow to think about how my page should be represented. I start off with data. The data gets passed into a component. The component is responsible for generating this React code, JSX or whatever you want to use. It creates effectively a virtual DOM. This virtual DOM then is diffed by Reagent or React with DOM, and ultimately it shows up in the browser. So the key things I feel like React takes care of for me is I create the components, it handles integrating those components with the DOM so that I don't have to think about it. I have a single path flow where there's no updates with the system. I just know, given this data, this component will always render this virtual DOM. And that is a massive, massive simplification. I don't have to worry about this updates that, this, and somehow this other thing can update whatever. I just know that for any given piece of data, this component will always render this DOM at all times, forever and ever and ever. Okay? However, I have an issue. Here's React code. This is straight from the to do MVC. This is the nice part of the React code. You can see this is JSX inside here. It looks a lot like HTML. This part is nice. You can get this. It's easy to reason about what's going on. This is a good thing. Let's go to the next page. However, to get there, what I start to see is there's a lot of these pieces here where I can reason about it, but it's starting to look less and less like that HTML that's built on the front page as the thing being so easy. I have to think a little bit harder about what's going on. Right, I have to understand what these props are, what onSave is, React create class. I'm starting to see the React framework firsthand. I start to have to know the React framework. And for me, that's not a wonderful thing. Let's go on a little bit further. Oh, sorry. Okay. This one for me, always makes me a little leery. In the to-do MVC, there's a should component update. It's a callback, but it's the comment that makes me uncomfortable. This is a completely optional performance enhancement that you can implement on any React component. If you were to delete this method, it would still work. However, this little piece of code gets an order of magnitude performance improvement. I don't really want to have to think about this. I don't really want to write this. Okay, move forward. So this is what led me to Reagent. I wanted at the beginning to like React, just ReactJS by itself. It would make life a lot easier. There's a world of JavaScript developers. We can just do this. But I felt like React didn't give me enough. There wasn't enough of I don't want to call it framework, but enough structure around it to make me feel really comfortable developing applications in there. So then I found Reagent, actually after another longer search. So Reagent is just a minimalistic interface between ClojureScript and React. Now I should say when I started this, I'm not a Clojure fan. I didn't come off doing a lot of Clojure before this, but the power that I saw in Reagent made me think that this was worth learning, even if it required a new language, because I could be so much more productive in it. So the first thing I'll do this as, who here has used Reagent? Okay, about half. All right, then for the other half of you, this is your first Reagent component that I'll show you. I'm not going to explain it. Is there anyone who can't figure out what this thing is trying to do? Or what it probably does? And that's the beauty of Reagent, right? I don't have to explain it. It's immediately obvious what it does. And at some point you keep thinking, oh, there's going to be a trick. Some point it'll get complicated. It never gets more complicated. So let's go to a slightly more complicated example. Here's a component. I'm now going to, and these are from the Reagent site if you guys might notice. So here I have a component. It creates a div, as you might expect, with a paragraph tag which has some content in it. I now want to reuse this component to build a bigger component. So I just pass in this component, and it fits very neatly within the div. And it does exactly what you expect it to do. It wraps that with a div and a paragraph tag. And then one last one. Now if we talk about making more dynamic when we pass parameters in, here again we have the same construct where we take a component, pass a parameter in, and now we have a dynamic parameter name. And again, it works exactly like you think it would work. This is the thing that I think Reagent gets right. Nowhere in here have you seen me refer to React anywhere. React is way below the radar. I just get to deal with ClojureScript, and that's a very nice thing. So in terms of understanding it and trying to reason about what it's going to do, it's just creating vectors effectively, just nested sets of vectors in this hiccup format. All right, so go forward. So my favorite things then about it, and we'll get to the specifics here, there's 5 of them. The first, and this is one of the things I absolutely love, it's idiomatic ClojureScript. I don't really have to see React at all. In fact, with very few exceptions, I don't even notice that I'm writing in React. I just think that I'm rendering this stuff in this Jade, Haml, hiccup-like markup language. Go back one. So the key thing is, this is a bias of mine. I don't like writing in frameworks. I remember the days of MFC where, yes, it was C++, but not really. It was MFC. And so I don't want to feel like I'm just learning the framework and everything is within the framework, because the framework itself is another language. Second one. Data-driven. This one we have found to be huge. And data-driven in this particular case means if I think about most frameworks, you have a tendency to design from the UI and write components and interfaces first. When you do Reagent, you have a tendency to think about what does my underlying data model need to be? And once you understand the data model, then you render the components based on that understanding. It surprisingly speeds up your development significantly because you understand how the data is already arranged, so you can just render it to whatever you need. Third one. This is a love of mine also, mock APIs. Who here has ever started work on the front end before the back end was finished baking? right? The majority of people. The trick is, in many frameworks, how do you start coding this when the backend isn't there? Turns out, with Reagent and other ClojureScript frameworks, but when I think of Reagent, I think of this, I get to mock out what I want the API to look like, build as if it was there, and only have to, I can fake it. And then once I've stabilized what the UI needs, then we can press it and have the backend develop exactly what we need, as opposed to trying to figure out how to make the two meet up. Stay as a first-class citizen. For you guys who have made more complicated JavaScript apps, who here has had to reload the page, click, enter some data to get the app back to the state you want so you can work on the data that you're looking at? It might be like the third page of a multi-page form, etc. Show of hands? Yeah, again, pretty much everyone. Right. It turns out that is a huge time suck to have to do over and over again. What I love is because Reagent holds the state, I can just put the state into an atom and then immediately go to what I'm working on. So all that time I would normally lose having to click this, fill out this field, type this in, I don't have to lose. I go straight there. And the last thing is that, and I've said this before, but I love how simple it is to reason about. When you look at the application, you try to understand what it's doing, you generally understand immediately. Okay? All right, so what I thought I would do is actually crack open some Reagent and take those 5 principles and really put them to the test. So I know we started late. Can I get a time check? Oops. Okay. So let's see if this actually works. So probably doing the thing you shouldn't do, which is I'm going to do this live. This starter project is an empty starter project. It's the one that we've used for a bunch of projects. It only contains enough to get you going. So I'll begin the build process and okay, can you guys see it okay? Let me get rid of the stuff that I don't need. Okay. All right, this is Hello World as Reagent. In fact, maybe you can strip this down further. So this is the simplest Hello World application we can make. It just takes Reagent to render content onto a page. So let's say, for example, the application we're trying to build is we want to take weather data from Open Weather Map, and we want to render to the screen and allow the person to basically choose which city they'd like to see the weather for. Here's the first thing I love, which is we get to start with the data first. All right, I'm going to create an atom, and this atom will contain my app state. So the question is, what goes in here? I'm going to cheat, and I've already figured out what the API is. So there's Open Weather Map has an open API. It returns a JSON response. It kind of looks like that. And we'll say, you know what? Maybe this is good enough for our API. Let's just try that. So I'm going to go ahead and just grab it. And we'll say the atom will contain an element of our data, and we'll literally just paste in the data. And I've just pasted in raw JSON. The only 2 modifications I'll make is I'll convert the colons and the commas to spaces. And so we get that. Reload the page, we know that it's still working, which is good. Just so you guys can view this content a little bit better, what I've done is I've gone ahead and pre-masticated it. So format it in nicely so you can see it a little bit better. Still kind of hard to see, but you get a sense of it there. Okay. So I'm going to pretend like we have an API and this is on the other end of the API. It will just give us this content. In this case, the API already exists, but in many cases, the API doesn't. So let's start off and we'll create a component, and this component will be a form element. Does kind of what you expect. We'll have it take an on submit that will just say got submitted. And we'll take an input element, type is text, name is city, the placeholder is, I don't know, city. And we'll take our component and we'll just stick it in here, city query, and reload the page. And we see that, so great. Okay. The next thing we want some sort of rendering of our city. Or maybe, let's actually rename that. And we'll make another component called weather results. Great. This is not going to win any awards for look and feel, but you guys get the idea. So let's start making this thing dynamic. The first thing that we'll do is we want our weather results to actually have the data. I can see up here that if I call data, that's going to have a big map of our stuff. So let's go ahead and do that. We'll say let my data be equal to the app state data. And then we'll pass in the data to the weather results. And then here, I'll pass it in. I'm going to do the Betty Crocker thing and go in fast motion really quick. So what I'm doing is creating very simple weather results. Given some data, I'll extract the city name, I'll extract the humidity, and I'll create a div that has the city name and the humidity. Reloading the page. I get San Francisco 73% humidity. Not going to win any awards, but the speed that I can just take an API, automatically start getting to work, not have to worry that the team has built the backend or not is fantastic. Now the last thing we'll do is why don't we go ahead and populate this and make it live to really do, to make it do its thing. So the first thing is, what I'll do is when the data gets updated, I want to update my atom. So every time the user types in something, I'm going to update my atom and say form called city, and then this will be and so I'm going to collect my form data here. I'll just leave it empty for now. Okay, reload the page. And what I want to do is let's see, the city is oops. Thank you. Ah. I'm just pulling it out into a function so I can see it a little bit easier. Nope. All right, no worries. I can cheat and do the Betty Crocker thing and just pull out the version that I know works already. Still doesn't do it. Oh. Yay. Right. Silly. Okay, so all I've done here is I basically said, when the form submits, call this fetch weather method. The fetch weather method will get the city name and just alert. So let's go make it live, and I'm just going to go grab the query. So all I'm doing is just doing an AJAX get to the open weather map with the city that we have, and when the results come back, I'm just sticking the results whole hog into the data. So here we go. Yay! And there was great rejoicing. San Jose, whatever. So now we have a live active app. So for me, those are all the pieces, I feel like, of let's go back to this. All right. So for me, those 5 elements, and actually if we could just quickly go back through them. Just go back forward 5. So idiomatic ClojureScript, you saw we almost did nothing that said React. All of that was just pure ClojureScript. Very, very nice to work in. Flip down. Data driven, we started with the model first. So even if the API didn't exist, we got to fake it, which is also this one. Next one. State is a first-class citizen. You saw we could just reload the page and the data was already there. So we had already simulated a fetch of data of London, and had it pre-populated. And lastly, it's so easy to reason about. I know you guys were trying to follow along, and this is maybe your first time seeing Reagent. Did anyone have a hard time understanding what I was trying to do? Right. So going forward. Yeah. So for me then, Reagent filled in this last part. How do I think about the data? Reagent basically makes it easy. I throw the data into an atom, and now from the atom, the component will render, creating a virtual DOM. There's one last piece, and I'll be quick with this. So the last piece is reframe. Reframe is just a pattern. It's kind of a library, but it's more a pattern of how to do single page apps with ClojureScript using Reagent. Scroll down. Here are the 4 pieces. Design your app data structure. We already do this with Reagent. The new thing is register subscription functions, create components, that's old hat, and register event handlers. Another way to think about this is if you think about the Flux pattern, or if you think about Elm or some other frameworks, this is really just sort of the event model from it. So it makes it very clear that when your UI is causing updates, you're not updating the data directly like we just did in that example. What you're going to do is send an event, and the event will handle it. So if I go to the next slide, here's just a very simple example of how this might work. Registering an event handler is the delete to do. So when this event gets called, then this function will happen. Somewhere in my component code, there will be a call to dispatch, delete to do, ID. So what makes this nice is if I look at my component code, There's no logic in here. I'm just dispatching the event that I want. Somewhere else, I can have this handler to handle the event itself. So here, this is very easy to test. This is just a view layer. It's not really doing too much. Together, one more down. Together, they form that last piece that I love, that makes this whole framework so powerful for me. There is a single flow of data throughout the entire system. From my data, I render my component, which renders a virtual DOM, which renders against the real DOM, shows up in a browser. The user creates an event, which fires off a dispatcher, which is received by a handler, which updates the data. A single flow of data through the system makes the application so much easier to think about. So how did Reagent do for the things I kind of set out as the key things? For me, the answer is last one. Thank you.
Presentation. I learned so much from you. Thank you. I'm not going to talk too much about the algorithm detail and language aspect. It's more about presenting you a demo project that we did a few months ago. It deals with graph data. Along the way, I may have a couple questions for you and for you guys, thinking about how can you model the data in a functional aspect, like using ClojureScript. So let me go into this demo now. As you can see, this is a colorful graph. Inside this graph, each node is a person, and each connection, each link represents there is a collaboration happened between those two people. So this data was collected on a Box platform. You guys know Box, right? Yeah. So it's like Dropbox, but for enterprise. So let's say we all use Box. If you and I share some file, that's a good indication that we have some sort of collaboration going on. If you and I share files very often, then you get a thicker line. Later on, when I zoom into it, you can see there's this thicker line. So this project is done in 3D using 3JS WebGL. So we modify from open source graph libraries, add to our change it to suit our own need, run into a lot of problems like the circular definition things I talk about it. So let me show you the growth of a graph. By the way, this particular graph is from a construction company. And as you can see, there's a lot of small clusters. Like it's actually, each cluster is a construction site. You can see they're kind of loosely organized. It's almost like some sort of like tree or vegetable. Okay, so what I'm going to show you next is the health industry. There we go. The data is actually collected over a course of a 2 years span. So as the time goes on, you discover the collaboration among people, and so the graph gets more and more complete. That is health industry. It's quite different from the construction industry you just saw, right? So because we construct graph in 3D, it gives you an advantage that you can actually navigate in the 3D space. And you can go close to a local area and then examine the local in the background of the global. That's something I realized about doing things in 3D visualization. Can you imagine you have a forest? Right, forest is pretty big, right? So what if you have to compress forest into two-dimensional space? And now suddenly it's really hard to visualize. So if you can keep forest in the three-dimensional space, and then you have the flexibility of going into individual tree without the mass of all the other forest like collapse into one, and you can fly up, examine the whole forest at once. So that's something we learned through this practice, that when you visualize things in 3D, you have a few advantages. Like number one advantage, you can have much higher information density. So 2 years ago, we did similar kind of graph using my Facebook connection data. So at the time, we created an app called socialislands.org. When you log in with your Facebook credential, that's right, log in. So you get all your friends and how your friends are friends with each other. And from there, you can create a graph just like that. We have one problem, that when you have more than 1,000 nodes, the graph become incredibly busy. It's become hard to analyze the local topography in corresponding to global. So this graph has over 2,000 nodes in there. It doesn't look like 2,000, right? So the first reaction when we visualize in 3D is like, where did all the nodes go? Because they become so sparse. And it turned out because it's spread in the 3D space, it allows you to look at the local. For example, if I look at local cluster, and the rest of the thing is not like cluttered behind you. So that's one of the major advantage of visualizing things in 3D. I'm going to talk about a couple other things that we learned down the road. So I want to show you guys another graph. What do you guys think a financial industry will look like? Anybody want to take a guess? Separate clumps, okay. Financial, like a bank.
A small number of very dense clumps.
A small and very dense clump, that's good. Anybody else has any guess?
Reporting the single node.
Or reporting the single node? Did you work with financial industry before?
Consulted for Federal Reserve once.
So we'll see. Let's see. So this data is from a bank. And for the whole thing, this whole project was done for Box at their Box Work Conference last September at the Moscone Center. The reason to start this project is to really to show how the communication changed with this like online sharing service. So what's the best way to show the collaboration? By just visualize the collaboration. And we did a study of 7 different industries. You saw health, you saw construction, this is finance, and we also have a media, entertainment, software, legal, and a couple other things. Yeah. Well, I think you're right. Yeah. So now, imagine what will happen if this bank adopt a communication structure like a health industry. Can the bank still function normally? I don't know. It'll be interesting to find out. So one thing we have not yet done that we really want to do is do intra-industry comparison. Let's see, we compared the signature between a health industry, a bank, and a construction. But what if we have 2 banks, like Wells Fargo versus Chase, to visualize that data? That can reveal a lot more information. So we all work in the software industry, right? How do you think the software industry communication structure look like? There's no chaos. Okay. Anybody else want to guess? Yeah. Let's show it. Yeah. It seems like we all have very strong intuitions.
Is this within one company? Or
It's from one single company. So in this case, the yellow dots means internal employee. Do you guys see this like thick lines? Somehow between those two people, there's a lot of file sharing going on. So the pink dots are external people, and you guys are right. It's pretty structureless. Now, the question is that good or not good for the software industry? We don't know. We have to find more data points to do correlation. But it's pretty telling that shows you the different requirement in terms of communication structure from different industry. There is a saying that the communication structure pretty much determines the power structure. I don't know who said that. Who? Comrade. Who is that? Conway. Oh yeah. I think it's makes sense, and it's also. Can you imagine if a military had this kind of communication structure? It's probably going to be disaster. Now we developed this in 3D. Of course, like with 3D, you want to find out how to navigate through city. Can you get to get retail? Yeah. So if you watch here, I have a Kinect V2. And let me, so let's see if I walk in front of a Kinect V2, you see my shape over there. So that's me. That's me, I can move around. And that's our interface for dealing with, for navigating through the data in the 3D space. Let me, oh, I might be in trouble. Let me go from here. So when you get close to a node, if you set some property about the node, it will pop up. And afterwards, we're gonna leave it on. So if you're interested, you can come play with it.
Can you pick a node?
For this demo, we didn't put too many information up here for the node. You can come closer. This gesture is still pretty experimental. It's the first step, how you deal with a 3D data object. The next step naturally is like how do you interact with the individual node? How do you interact with the region? Interact with the global? So it's an ongoing project. We just really barely scratched the surface. Well, I promised to tell you a little bit things that we learned from doing this project. Like one thing we really felt that is like when you look at things. Thank you. When you look at object in the 3D, because right now when we deal with data, we look at the chart, we look lines, pies, bar charts. It's mostly in 3D flat. But we grew up in the 3D world. When we were born, we already learned like this is a mouse. We just pick up the mouse, and we don't use a mouse to drive it to make it comes up. So a pen, I can directly access the pen. So when you have object present in the 3D format, it's a much direct mental image that in your brain, and it's a faster and more direct interaction with it. But again, how do you take advantage of this? Maybe how can you use this to help how we understand the data and how we create a mental image, mental model of data? That's a lot of research needs to be done. I know for genetics, they have been using 3D model for a long time. Like, imagine a protein model. If you have to use two-dimensional description to reconstruct a 3D model, it's pretty hard process. I know in the construction business, people does it. In the architecture, you're creating like a blueprint of a two-dimensional, like whatever layout, and you reconstruct a mental image of a three-dimensional brain. It takes a lot of special training. But if you have a model in front of you, it's very easy to understand. So come back to Kinetic Arts. Kinetic Arts was originally developed as a dance and interactive technology company. So we kind of have to create a dance mode for the thing. And you have to see our dancers doing that. So I'm just going to demonstrate a little bit. And what happened here is my hand become attractors, and my spine movement creates wind and energies that moves it around. So you can create mapping of how your gesture and how your body, how your skeleton positions related to the physical force that in the simulation and create a movement. So I think that's all I want to say. By the way, we have open lab every Tuesday night from 8 to 10, where a lot of artists and programmers come together to experiment new ideas, new way of performance. So if you guys are interested, talk to us. And one particular thing, come back to the ClojureScript. I'm really interested in how to model a graph data with a functional language. And maybe I'll talk to you later to get some help from you. Yeah. Well, thank you guys.